Hi, today we're going to be talking about AP Calculus 2023 FRQ number 3. This was on the AB and the BC portion, and it's a differential equations question. So let's get started on this problem. Okay, let's get started on this now. So here is our question for question number 3. It looks like this. If I were you, I would pause this video and I will try it on my own. But we're going to get started, just you and me together. So a bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed. The increasing function m models the temperature of the milk at time t, where m of t is measured in degrees Celsius and t is the number of minutes since the bottle has been placed on the pan. M satisfies the differential equation dm over dt is equal to 1/4 of 40 minus m. At time is equal to 0, the temperature of the milk is 35 degrees Celsius. It can be shown that m of t is less than 40 for all values of t. Okay, let's just talk about this equation. So we are told about a function m of t, where m is our output, t is our input. And our output there is the temperature in degrees, more specifically degrees Celsius. Okay, so we are given that bits of information. We are also given the derivative, the dm over dt, the change of our temperature with respect to time, and that output would be our Celsius, degrees Celsius over our minute in this case. So just a couple of things, just basic stuff. We are given m of t, that's our output of degrees, and we are given dm over dt. We are also given the initial value at t equals 0 is 5. So I know that m of 0 output is 5. All right, so now using that bits of information, let's tackle the rest of this problem. So a slope field for the differential equation, dm over dt, is given by this again. It is shown, sketch the solution curve through the point 0, 5. All right, so I got to start at 0, 5 of my slope field, and I've got to follow the trend. Follow my slope field lines. Booyah. Big thing here, you're not breaking through any of those lines. You are going along it. You're going parallel to all of them because that's what our curve is doing. It's going parallel to all those slope field lines. And make sure you start at your initial and you end at the end of the graph, or if you end at a vertical line. All right, let's do problem number 2. So use a tangent line to the graph m at t is equal to 0 to approximate m of 2. The temperature of the milk at t is equal to 2 minutes. So we want to estimate m of 2. We want to figure out what that y value is using tangent line approximation. So I got to build a tangent line. So I need my x, my y, and my slope at a certain value. So let's do that thing. So our x for approximation is going to be at t equals 0. Our y is going to be the output. So we know our output at 0 is 5. And our m, we need to use our derivative. So we know it's 1/4 of 40 minus m. What's our m at this point? What's our output at this point? That is 5. So I'm going to be 40 minus 5. That is going to give us 1/4 times 35. 35. And that will give us 35 over 4. So that is our slope, our dm over dt at 0, 5. Now, let's create this tangent line. So that will be y minus y1 is equal to m, x minus x1. That is our point slope formula for a line. Let's plug in what we know. Our x is going to be 0, so we're going to have x minus 0. Our m, our slope is 35 over 4, and that's equivalent to y minus 5. Let's simplify and move that y over, that 5 over, so we have y is equal to 35 over 4 times x plus 5. All right, and last but not least, let's figure out what this new y value is if I input our 2 into our tangent line. So that will be y is equal to 35 over 4 times 2 plus 5. 35 over 4 times 2, that 2 and that 4 is going to cancel out. So we get y is equal to 35 over 2 plus 5. Let's get like denominators for that 5. So that would be y is equal to 35 over 2 plus 10 over 2. And that's equivalent to 45 over 2. And that is our estimate. Bingo! All right, let's move on to part C. Part C states, write an expression for dm over dt. So I know that is the second derivative in terms of m. Use d squared m over dt squared to determine whether the approximation of part B is an underestimate or an overestimate for the actual value m of 2. Give a reason for your answer. All right, so let's take the second derivative. So let's start with my first derivative, that dm over dt, which is just given to be that 1/4 40 minus m. I can clean that up a little bit, right? I can distribute that 1/4 in. So I would really get that to be 1/4 times 40, which is 10. Then minus 1/4 m. Let's now take the derivative of that sucker. So d squared m over dt squared. That's then equivalent to the derivative of 10, which is 0. Then the derivative of 1/4 m, let's use the power rule. That would be our negative 1/4 chilling outside. M, what's it going when I take the derivative of that? That is just going to go away, and I'm just going to have that dm over dt. So it'll be times dm over dt. Now, I'm not finished here because they want us to have the derivative in terms of m. So I have to plug in my original dm over dt in for this. So that would then be negative 1/4 times 1/4 40 minus m. And that is our second derivative in terms of m. And if I want to get even more fancy and simplify, I can multiply that 1/4 by the negative 1/4 by the 1/4, and I can get that negative 1 over 16 40 minus m. All right, now let's move on to our next aspect here. So use dm over dt to determine whether the approximation of part B is an under and overestimate. So that is stating, hey, if my function is concave down, aka our d squared m over dt squared is less than 0, we know our function is concave down. So no matter what my tangent line is, anywhere here, if it's concave down, it's always going to be an overestimate to our curve. It is the opposite if I am looking at my second derivative being positive, aka concave up. Therefore, whenever I draw that tangent line, it could be any one of those values, it's always going to be an underestimate. So we have to figure out what is our concavity at this time. So I really have to say, hey, d squared m over dt squared is that negative 16 40 minus m. So we are multiplying our 40 minus m by negative. So it's going to stay negative if 40 minus m is a positive number, and it's going to be a positive slope, a positive second derivative, if that 40 minus m is a negative number. Now, remember what I said about earlier, that everything that College Board states is super important. It can be shown that m of t is less than 40. Therefore, all of this has to be a positive value, since m of t, our m value, is less than 40. Therefore, our d squared m, our second derivative, is going to have to be some negative number, because we have a negative 116 times that 40 minus m, which has to be a positive number. Therefore, m is concave down, therefore our second derivative nope. Sorry. Not our second, therefore our second derivative, therefore our tangent line is an over approximation one more thing I'm going to change. I'm going to change this notation over here. I don't like that it's equal to a negative. I really like that it's less than 0. Okay, that d squared over t squared m over dt squared is less than 0. Concave down. Okay, and that is question number 3. Okay, so people, let's take care of this problem number letter D. So we are going to be using the separation of variables to find an expression for m of t. The particular solution to the differential equation dm over dt is equal to 1/4 40 minus m with initial condition m of 0 is equal to 5. All right, so let's first separate those variables. So let's write our differential equation that dm over dt is equal to 1/4 40 minus m. All right, so what I want to do is I want to separate the variables so all of our m's are on one side of our equation, one of our t's are on the other side of the equation. Okay, so what I'm going to do is look at our differential equation. Notice that dm is in our numerator on the left-hand side and our dt is in the denominator. I want all of my dm and dt to be in the top. I want them to be in the top so I can integrate, they're in the numerator. So what I'm going to do is I'm going to multiply both sides by dt. So I get dm is equal to 1/4 40 minus m times dt. All right, and now we still have m on the right-hand side, so I need to multiply that whole expression, that 40 minus n, to both sides. So I'm going to divide. So our new equation after doing some rearranging would be dm over 40 minus m is equal to 1/4 dt. All right, now let's integrate because we want to get our general equation back. We want to get the OG. I started differentiating. Now I need to get back to integrating. So let's integrate it to get back. That's not the integration symbol, Mistler. There we go. That's much better. Okay, so let's handle that right-hand side, that 1/4 dt. I can just rewrite that as 1/4 t plus c, just using the reverse power rule. The other side's a little bit more challenging, so let's do that real fast. That d, I'm going to rewrite that as 1/40 minus m dm. All right, so let's do this thing. I'm going to have to use u sub here, so I'm going to let u be equal to 40 minus m. Let's rewrite that in terms with u in it. Okay, now I need to replace our dm with du, so we have to take the derivative with respect to dm. So that will be -1. Rearrange that, get dm by itself, so we get du over -1 is equal to dm. Plug in, so we get times du over -1. I can take out that -1 now out of my integral, so we have negative integral 1 over u du. Integrate that, that would be negative natural log of u. Ooh, don't forget your plus c. And let's replace that u with our initial equation for u, and that was 40 minus m, so it's negative natural log, absolute value of 40 minus m plus c. All right, let's now plug that back into our original equation. So it's negative natural log of 40 minus m plus c. Okay, so now let's do a little bit of just rearranging. We have a c on the left and the c on the right. If I would subtract the c on the left over, okay, if I would subtract that over, it will be a constant minus a constant. The answer is still a constant. So I don't need both c's. I only need one. So I'm going to rewrite this as a negative natural log of 40 minus m is equal to 1/4 t plus c. All right, now let's figure out what is our constant. How do I figure that out? I use our general term here, that m of 0 is equal to 5. If we think about that m of 0 is equal to 5, I have to think, what is our input? What is our output? Our input is 0. Our input is our time variable. So that is t. Our output is our m, aka our degrees Celsius of our milk. So that is our m. Let's plug those points in. So then we have negative natural log of 40 minus 5 is equal to 1/4 times 0 plus our constants. Oh, heck yeah, we can do some simplification here. So negative 1/4 times 0, that just gives us 0. 0 plus c is just our c. Bingo. Negative natural log of 40 minus 5, that's just negative natural log of 35. We found our c value. Heck yeah. Let's plug it back in now. So we have negative natural log of 40 minus m is equal to 1/4 t minus natural log of 35. Booyah. Now, we just gotta get m by its heckin' self. Let's do that. We gotta just break it down. Break that left side down, go outside in, get m by itself. So first off, I have negative natural log of 40 minus m. I have to take care of that negative. Divide both sides by -1. So we get natural log of 40 minus m. Absolute value of 40 minus m is equal to negative 1/4 t plus natural log of 35. All right, one step closer. Let's ask ourselves, what's next? What's farthest on the outside and the left-hand side? That is natural log. How do I get rid of natural log? I do e to the power of both of our sides. E to the power of natural log of 40 minus m is equal to e to the power of negative 1/4 t plus natural log of 35. E to the natural log, they cancel each other out. So I'm just left with what's left in the exponent, which is that absolute value of 40 minus m. And that's equivalent to e to the power of negative 1/4 t. I'm going to do something a little bit different here. I'm going to use the idea, a basic exponent rule. So if I had x to the 4th times x to the 3rd, I could rewrite that as x to the 7th. I could add those exponents together. So I'm going to do the opposite here. Since I had adding exponents here, I can rewrite that as e to the power of natural log of 35. All right, let's keep going. I'm going to move up here. Okay, we have to get rid of absolute value of 40 minus 5. Okay, let's think about this just in general. I know from the beginning that m of t is less than 40. Our output of m is always less than 40. So in this case, 40 minus m, is that ever going to be a negative number? No, that 40 minus m is always going to be positive. So that absolute value is really extra. Do I need it? No, it's just a really extra, it's an extra step that's not a necessity because my 40 minus m is always going to be positive. So I can just forget about that in this situation. So we can just leave that 40 minus m and have that e to the negative 1/4 t. And then we have e to the natural log of 35. What did we just do? Natural log, e and natural log, they cancel each other out. So I'm just left with absolute value of 35. Absolute value of 35 is just 35. So it's times 35. All right, now get m by itself. Gotta get rid of that 40. How do I do that? I subtract that over. So we are left with negative m is equal to 35 e to the negative 1/4 t. In this case, minus 40 now. Lastly, get m by itself, divide by -1 to both sides. We get m is equal to negative 35 e to the negative 1/4 t plus 40. And that is our particular solution to that differential equation. We heckin' did it. Let's go. All right, let's now talk about how these AP graders graded this FRQ. Okay, so for the first question, this is where we drew our slope field. You got 1 point only for drawing your particular solution through 0,5. You got 1 point, okay? Pretty simple stuff there. For our second one, we had to use the tangent line to figure out, hey, what is our value of our tangent line, value of m of 2? You got 1 point if you identified your slope at 0,5. And you also got 1 point if you had the correct approximation. Again, you could have stopped right here without simplifying and you could have gotten that value. All right, let's talk about part C. Okay, part C, you also got 2 points. You got 1 point if you found the correct second derivative in terms of m. You got a point, and your last point came to that came from your explanation that it is an over approximation because our function is concave down. And lastly, this last problem, you got 1 point if you correctly separated your variables. You got another point if you correctly found both antiderivatives on both sides. You got 1 point if you found your constants using your general term, and you got 1 point for your final answer. And that is how they scored that AP question for this FRQ. And that is this FRQ video done. I hope you found this video helpful. We dissected this FRQ for this differential equation. There was a lot of calculus in it. This is always going to be the calculus-heavy FRQ question if you get a differential equations. So I hope you found this video helpful, and I hope you find this whole series helpful. And good luck on your AP test, and go check out some more videos. Thank you for watching.